show my screen. You're able to see my email with the Safety Academy page?
Yes.
Okay.
Yes.
All right. Good morning, everyone. My name is Anthony Chamot from Tyndale Oliver. Quick little blurb that I always do in the morning. Everyone that is here received this invite from GoToMeeting that gets you to this location. Dennis's email, our Safety Academy coordinator, is here. Questions about topics or upcoming information can go to him. Any feedback or technical issues, here's my email, can go to me. Important links on this is the link down below for the Tampa Bay traffic safety site that has information on the upcoming webinars, as well as the recordings for the webinars that have occurred. That tells you here the webinar for today, April 25th. We have Larry Hagan presenting for us. On July 18th, we'll have Joe Santos presenting on lane departure initiatives, completed webinars for 2018. And the recordings for those, all the webinars going back to 2013, the presentations as well as the recordings. These are recorded. On the resources page, as well as in the handout pod for GoToWebinar, are the handouts and additional information for today's Highway Safety Manual presentation that Larry is giving. And here we have the PDH request forms as well for professional engineers that are seeking credit for these webinars. With that, I will hand it over to Dennis for his official introduction.
Anthony, if I could real quick, I just want to point out, yeah, some of the resources there, we were limited to how many resources we could upload into the handout pod. But if you go to the traffic safety website here, there's FDOT user guide on using the highway safety manual, and that thing that's 1, 2, 3, 4. The fourth one down is NCHRP's user guide on using the highway safety manual. Both of those are excellent resources. The HSM manager's guide is a resource that's really tailored at the manager level and gives you a real high-level overview of highway safety manual. So there's some excellent resources there, and avail yourself of those if you like.
Thank you, Larry.
All right.
See my screen, what?
Yeah, we can see your screen, Dennis.
Okay. Good morning. This is Dennis Balloon, the FDOT Local Agency Traffic Safety Academy Coordinator and a consultant. And I'd like to welcome you to the third webinar for the 2018 FDOT Local Agency Traffic Safety Academy. Today's safety webinar topic is Highway Safety Manual Applications for Local Agency Safety Projects, and being presented by Larry Hagan, PE. He's with Hagan Consulting Services out of Georgia. There will be some poll questions today during the presentation. I just wanted to share that with you. I also want to let you know a little bit about Larry. He's worked in the public sector, the private sector, and academia. He holds a bachelor's and master's degree in civil engineering from the University of Florida. He's a registered professional engineer in Florida and Georgia, and is a certified professional traffic operations engineer. He's got over 30 years of experience doing transportation engineering work throughout the state of Florida. And he's currently working with various districts, DOT, and also with Puerto Rico Highway and Transportation Authority on implementation of a strategic highway safety plan for their with that, I'd like to begin my little introduction I normally give to everybody. This is the FDOT Local Agency Traffic Safety Academy, and this academy has been put together to provide information for you on safety-related issues to enhance your safety program. This is the 6th year of the program. They usually are in a 2-hour increment from 10 a.m. to 12, and they are scheduled to the end of December. They usually run between an hour to 2 hours, and that usually depends on the complexity of the topic. And there's a couple links that Anthony kind of went over already about registration and how to get to the Safety Academy webpage. And like I said, today we're having the topic highway safety manual applications for local agency safety projects presented. And we do have another one scheduled for July 18th, Lane Departures and Initiative. And I would like you to know that there will be other ones coming, so look forward to that for May and June and out beyond July. And also those that are planners, AICP planners, we do provide the information to AICP to be credit for that. And then for the PDHs, as Larry mentioned, you can download the form and submit this to Larry. But I also like to mention to you that you need to fill out the PDH form and submit it at the end of the webinar. It's really easy to fill out, and just mail it to Larry at the address shown on the form. It's really best to submit them right after the webinar rather than waiting until close to your license renewal deadline and trying to remember which sessions you attended and which you didn't. So with that, this will end my segment, and just say this is my contact information. And if you have any questions about the Safety Academy, please let me know. And with that, I'll turn it over to Larry Hagan as our presenter.
All right.
Larry, you would like the first two poll questions right away?
Yeah, go ahead and do the first two poll questions.
All right, so we're going to begin off the bat with a poll question, interactive webinar. Make sure that everybody's awake. On a scale of 1 to 5, ranging from I can spell the HSM to I've had a lot of training and know a lot about the Highway Safety Manual, what is your knowledge of the Highway Safety Manual? We'll give folks a few seconds here. About 70% of the audience has voted. Looks like this is definitely a timely webinar based on the responses so far, Larry. I don't know if you can see them live in the poll chat or the poll pod as they're coming in.
Yeah, I'm looking at them in the poll pod. Yeah, it looks like a very timely webinar. So,
all right, we'll go ahead and close this and share the results with the audience. We've got 13% of our audience classify themselves as the lowest level of knowledge. I can spell HSM, 34% level 2, 32% mid-range at level 3, 17% at level 4, and 4% of the audience considers themselves an expert on the topic.
Okay. Well, those 4% we can use as assistant instructors. So when tough questions come up, I might defer to them. So that's a good thing. All right.
And second poll question, same scale. On a scale of I can spell HSM to I have used HSM predictive models and empirical-based analysis, what is your level of experience with using the Highway Safety Manual on projects? So related question, but slightly different. The first one was on your knowledge, and this one was on the application. Are you actually using it? As we were talking a little bit before the webinar, Larry, it looks like this one's ranging a little on the lower side. So although people have training on the Highway Safety Manual, it seems like less people are actually using the Highway Safety Manual.
Yeah, there are a few out there, and I presume those are the same people that will be my assistant instructors, so that's good.
Let's close this poll and share the results. 33% level 1, 38% level 2, 21% level 3, so definitely skewed towards the less experience. Only 2% level 4 and 6% folks that have used the Highway Safety Manual and empirical base.
Yeah. Okay, and I mean, that's kind of what I expected. It was, like Anthony said, something we were talking about beforehand, that, you know, the Highway Safety Manual came out in 2010, which, 8 years ago. And, well, actually, it was right at the end of 2010, so 7 years ago. But still, a lot of people haven't grabbed hold of it and aren't really using it to its full capacity just yet. And so hopefully this will be timely, give you some information about where it might be applicable, but I'm also going to talk about a lot of things where it's not applicable and where you really can't use it now, and why I think a lot of people aren't using it. So hopefully this will provide you some useful information. Okay, I presume you can see my screen now?
Yes.
Okay, good deal. Okay, and so did that, you see my face now?
Yes.
Okay, yeah, so I've spent a few years with my nose in the Highway Capacity Manual, as you can see, and I want to share some of what I've learned out of the Highway Safety Manual. I think it's the Highway Capacity Manual, Highway Safety Manual. I want to share some of that with you today. Hopefully, you'll find some interesting information here that'll help you in knowing when and how to use it, and how it might help you in your local agency safety projects. I always start with my standard disclaimer. It's real small, but what the small print basically says is you're not going to be a HSM expert at the end of just one-hour webinar, but hopefully you'll learn some stuff here, and with the resources you can download, be able to educate yourself and learn a lot more about when to use it, how to use it, and why it's applicable in some cases and not applicable in others. The meat of this presentation really comes from a couple of webinars that I've got on my own website for people to watch on Highway Safety Manual. One of them is a background of the Highway Safety Manual, gives you a lot of introductory info, and then part 2 of it gets a little deeper into the content. And again, both of those are recorded and they're out there. And later on, if somebody's interested, I can tell you how to get those at a discount. So anyhow, some information there, and what I'm going to show here is pulled from parts of those and some new stuff thrown in there. But I want to begin with some questions. These are, standard questions, people may be asking as they're trying to familiarize themselves with the Highway Safety Manual. What is it? Who should use it? When should we be using it? How do we use it? Where can we get help on using it? And why should we use it? And so I hope to answer some of these questions and maybe a few others as we go through the webinar. And, let's dive into this and see what we can learn, introductory. There is some real basic introductory level stuff here, but we'll get a little deeper into some of this stuff. All right, what is the Highway Safety Manual? It's a AASHTO publication, provides information and tools to help you conduct quantitative, that means there's a number, a quantitative safety analysis. The real emphasis in coming up with it is to do quantitative analysis. And the real impetus was to be able to come up with numbers that we can then turn into dollars and then use that to really analyze, what's the safety impact of doing different design options. And if we can equate it to dollars, we can hopefully show that there is a huge benefit, much, much greater than the cost of putting in different safety features into a design. So again, it's trying to quantify in, dollars, if you will, the safety impacts of different design decisions. And so again, the real point of it is to facilitate explicit consideration of safety throughout the project development process, so that we're not just designing to the standards, but can we go beyond the standards maybe to make a real safety impact, especially if we're looking at a project where we know we have safety issues. We have a crash history that shows there are safety issues. And so what's the benefit for putting in some of these countermeasures that may go beyond doing it by the standards, doing the standard business as usual treatment? Do we get a huge safety benefit? Can we really reduce crashes? Can we really expect to save lives, reduce fatalities, reduce serious crashes by implementing some of these safety measures? And again, that's what the Highway Safety Manual is all about. Can we quantify it? Can we quantify how much benefit we're going to get from trying these different things, from doing these different things in our design projects? And again, that's the real focus of the Highway Safety Manual. It is a compilation of a lot of different methods for developing an effective roadway safety management program. The first few chapters, the first volume of the Highway Safety Manual gives you a lot of background and information on a good highway safety management program and how to assess the benefits. The predictive methods we're going to talk some about. That's the second volume in the 3-volume set of the Highway Safety Manual. And so the predictive methods, part C, to help you estimate the crash frequency and severity and again, support project level decision making. And then part D of the manual is the catalog of crash modification factors for estimating, the effect of a variety of different operational treatments or geometric changes. And so we'll look at these things in a little bit of detail as we go through the slides here. The Highway Safety Manual is designed to be like the Highway Capacity Manual. The folks on the Highway Safety Manual Committee, they saw the success and all the things that have happened over the last few decades with the Highway Capacity Manual, and they said, hey, we want to make the Highway Safety Manual just like that. And so, again, the whole goal of the committee is to make the Highway Safety Manual the safety equivalent of the Highway Capacity Manual. And so, again, it's designed to help you, the transportation professional, understand and quantify, put a number beside the expected safety performance of different design options and help you make an informed and balanced decision. And, that helps with doing data-driven processes. One of the things in the federal safety regulations is it's requiring all the states to have a data-driven process. And so there's got to be data behind spending of HSIP money. And so we want to show data. We want to show quantities. We want to show numbers that can show, we've got data to back this up, that we're doing something that's going to reduce fatal and serious injury crashes. And this is how much we expect to reduce by doing this particular project. And so, again, that's the emphasis of the Highway Safety Manual, is that coming up with quantitative estimates so we can have a data-driven process. And again, the HSM is an attempt to do all the stuff the Highway Capacity Manual has done over the last 30 plus years, and and just apply that to safety. And so it's you get definitive numeric outputs. It represents the state of the art in safety practice. It's widely accepted within the practice of transportation engineering and based on real science and updated regularly to reflect ongoing research. And so again, that's what we're trying to do in the Highway Safety Manual. So again, that was the goal of the committee that is behind the Highway Safety Manual. That's what they said. We want to make the HSM just like the HCM, except for safety. And so that was their very much stated goal. And I heard that loud and clear. I went to one of the very first, the pilot training for the Highway Safety Manual just before it was released. And as I was sitting there and they were talking about that, it took me back to my graduate school years. This is the cover of the 1985 Highway Capacity Manual. And that was the year I entered graduate school, just as the 85 Capacity Manual was released. And so one of the things, I'm a transportation engineering graduate student, and here is really it's the first modern Highway Capacity Manual. There was a 1965 manual, but it was real small, and it was really a beta version, if you will, of the Highway Capacity Manual. There were some interim materials, but the 85 manual was really the first real modern capacity manual. And it was just an incredible time in my life in that, here I was studying the Highway Capacity Manual. I'm at the University of Florida, and shortly after that, University of Florida is awarded the McTran Center. And so, we get the McTran Center contract from Federal Highways, and we are the nation's distribution center for highway traffic engineering software. And one of the things that was developed right after this 85 capacity manual was the highway capacity software. And people like me with some gray hair, been around a while, remember that first version of the highway capacity software, a DOS version. I mean, it was before people had Windows on their computers, so you had this black and white, DOS version of the highway capacity software, and that's how you typically did your highway capacity analysis. And so, like I said, this was, my graduate school years, this 1985 capacity manual, the first modern highway capacity manual, and it had within it worksheet type analysis procedures. It was set up so basically you could do all your analysis, in a spreadsheet. And you started in all of the different facility types. You started with what are the ideal conditions, and typically, 12-foot lanes, paved shoulders, on high-speed facilities, level terrain, and all these kind of things. These were the ideal conditions. And then you had adjustment factors for anything other than ideal. Now, since then, since that 85 version, there's been numerous research reports, numerous papers, a lot of research done in highway capacity. The models have been updated, new parameters introduced. They had updated manuals in 1994, 1997, year 2000, the year 2010, and actually the most recent update is the 2016 Highway Capacity Manual, now called the 6th edition of the Highway Capacity Manual. But a few years back, what they did is they completely abandoned that worksheet format and said, we've got really complex procedures now, and so we're going to do it all via software. Nobody does it via the worksheets anymore. We just presume somebody's going to be doing something like highway capacity software. And like I said, this is, you'll see my connection here to this in a minute, but this is my grad school background, and I was one of those, took that 1985 highway capacity manual, and I'm a grad student, and I'm I've got my nose buried deep in it, and I'm studying it. And so my master's research, I developed the LTH model. And LTH here means the left turn handling model. It had absolutely nothing to do with the fact that my name is Lawrence T. Hagen. No. What's in my report presented to TRB was the left turn handling model, because that first version of the modern highway capacity manual, the 85 version, really overestimated the capacity of the permitted portion of protected permitted left turns. I mean, it greatly overestimated the capacity, greatly underestimated the delay of protected and permitted left turns. And so that was really my master's thesis, if you will, was describing that and coming up with a new model for uniform delay for protected plus permitted, or leading or lagging permitted plus protected left turns. And so that was some of the research, and I added something to that. Later researchers took what I had done and made it even better. And so anyhow, that's my contribution, if you will, to the field of capacity. So again, like I said, that 85 capacity manual was the first modern highway capacity manual. Worksheet type analysis procedures. It started with, here are the ideal conditions for all these different roadway types. And then we have adjustment factors for anything that's different than the ideal. Now let's look at the parallel, the 2010 Highway Safety Manual. It's really the first ever highway safety manual. It has worksheet type analysis procedures. We start with the ideal conditions, or what they call the base conditions in the Highway Safety Manual. And then there's adjustment factors for anything other than that ideal. Does that sound familiar? Yes, I mean, they are actually walking in the footsteps of the HCM. And so, I see the future that over the next 30 years, many students like I was, many master's students and PhD students will be doing a lot of research and continuing to add to the field of safety knowledge. And so, the 2045 Highway Safety Manual will probably have all kinds of really elaborate, complicated things that have been added to it, but we'll all be analyzing this using the highway safety software. And so that highway safety manual in 2045 is probably going to look really slick and be something a lot different than where it is right now. All right, like I said, what the highway safety manual is, it's designed to be like the highway capacity manual. It describes mathematical relationships for safety performance, based on exposure and the roadway conditions. It's an analysis tool only, just like the highway capacity manual. It doesn't have standards nor best practice guidance, and so it doesn't supersede other publications that do. So it's not like the MUTCD and the Green Book, where it says you shall do this or you shall do that, or this is the way to do certain types of things. It is an analysis tool only, doesn't have standards. And so that's an important thing to remember about the Highway Safety Manual. It's also the product of $7 million 10-year research program, and so a lot of agencies putting their money into lots of research going on here, thousands of hours reviewing, decades of research in the past. And there was a TRB task force on the development of the Highway Safety Manual. AASHTO also had a task force on the Highway Safety Manual with a multidisciplinary team from safety, design, and traffic engineering, all a part of that HSM task force. Well, again, what is the HSM? Well, when I first started doing this course, when the HSM first came out, well, the HSM was about $325 per copy. Unfortunately, it's not like the MUTCD, which is available online. You can download it for free and that kind of stuff. But actually, it's no longer $325 per copy because they've now added the 2014 supplement to it. If you are a member of ITE, you can buy the Highway Safety Manual, including the supplement, for $500. If you're not an ITE member, then the cost is $675. So it's a little bit hefty on the price tag there, but that's what it costs if you want to get a copy of the Highway Safety Manual. It's also about 3 3/8 inches thick, so it takes up a little bit of real estate on your bookshelf. So that's volumes 1, 2, 3, and the 2014 supplement. And so again, all told, it's a little bit less than 3.5 inches thick. So that's how much real estate it's going to take up again on your bookshelf. The 2014 supplement added some things into the Highway Safety Manual, and I'll talk about that in a little bit. But if you already have the first 3 volumes and you just want to add the supplement, well, again, if you're an ITE member, it's $175 per copy to get yourself a copy of that 2014 supplement. All right, so Highway Safety Manual, again, it's the first ever edition of the Highway Safety Manual. It really compiled a lot of research that had been done in the past few decades and a synthesis of all that kind of stuff. And some new research, put it all together in one volume is what they were trying to do. Create one volume, the go-to reference, if you will, for highway safety. And as I mentioned, there were, when it first came out, 3 volumes. There are 4 parts in the 3 volumes. And Part A is the introduction, human factors, and the fundamentals. Part B is the roadway safety management process. Part C is the predictive method, and Part D is the crash modification factors. And we'll look at these in some detail, but we're not going to spend a whole lot of time on Part A and B. Most of the emphasis, the real meat, if you will, of the Highway Safety Manual is in Parts C and D. When you get the 3 volume set, before the supplement came out, Parts A and B are in Volume 1, Part C is in Volume 2, and Part D is in Volume 3 of the manual. So let's look Part A, and again, it's the introduction, overview of the Highway Safety Manual, talks a little bit about human factors, talks about some of the fundamentals of doing safety analysis. Then Part B gets into the safety analysis process, if you will. And it starts, Chapter 4 is network screening, and then diagnosis is Chapter 5. Countermeasure selection is in Chapter 6, and how do you select the appropriate countermeasure. Chapter 7 is all about economic appraisal, how you then convert the numbers you come up with into dollars, and doing benefit cost analysis and net present value and stuff like that. That's in Chapter 7. Chapter 8 gives you information on prioritizing improvement projects. And Chapter 9 is safety effectiveness evaluation. And so this is Part B, if you will. And Part A, Chapters 1, 2, 3, and these chapters here, Part A and B are together in the first volume of the manual. Now, before I get into Part C and D, who should really use the manual? Who should be using the Highway Safety Manual? Well, certainly I think if you're planning, that's one of the things we want to do in using the Highway Safety Manual is, we'll look at the predictive methods in a little bit. So as you're doing planning and you're planning roadways, again, we want to include safety features in the roads that are being planned. So certainly planning should be using the Highway Safety Manual. If you're doing design, again, you want to make sure the elements you bring into your design are bringing the safety measures that you want also into the design. And so design should be using the Highway Safety Manual. Operations, the folks that are watching the road operate and doing traffic operations work, they should be using the Highway Safety Manual. And maintenance also should be using the Highway Safety Manual, because you're seeing these crashes occur, and are the things being maintained properly? And if the things aren't being maintained, we should expect to see a decrease in our safety performance. So when, that's the who, now when should we be using the Highway Safety Manual? Well, for projects that are in planning, or things that are in design, or things that are operating, or things that are being maintained. So again, all these different areas within the organization, whether it's a local city or county agency or DOT agency or whatever, should be aware of the Highway Safety Manual and possibly using these things. All right, so that was the who and the when. How should we use the Highway Safety Manual? Well, let me tell you, and what you will see in the remainder of this presentation, how we should use the Highway Safety Manual is very carefully. There's a lot of things in it, and you want to be aware, how to use it and when you should not be looking at it and not using it. So again, be very careful in using the Highway Safety Manual. Again, we looked at the 4 parts. And as I mentioned, the meat of it is really Part C and Part D. A lot of people really excited about Part C, and so whenever you see Highway Safety Manual training, or you hear people talking about the Highway Safety Manual, they're going to tell you all about Part C, in particular, the predictive method. And so let's start in that, look a little bit at this predictive method. What is it and what does it do? And so, in the first 3 volumes, I'll get to the supplement in a little bit, but in the first 3 volumes, what came out, Part C, the predictive method, covered 2-lane rural roads, rural multi-lane highways, and urban and suburban arterial highways. And for each of these different types of roadways, the common procedures in Part C, there's safety performance functions for each of the different types of roadways, and appropriate crash modification factors that go with that, and then a calibration for local conditions. And so, again, this is what Part C consists of in the Highway Safety Manual. And these are the facility types that have safety performance functions in Part C of the Highway Safety Manual. And so, again, rural 2-lane roads, rural multi-lane highways, and urban and suburban arterials. And so you can see for the roadway segments, undivided or divided, and then for various intersection types, the safety performance functions exist for some, but not all of those possible configurations there. Now, one of the things you may notice here, and especially if you're with a local city or county agency, you don't see really anything in there about urban and suburban 2-lane roads, like local roads. It's not covered in the HSM. Urban and suburban collectors. Well, collectors are a little different than arterials. Again, it's not covered in the Highway Safety Manual. It's really interesting to me, chapters 10 and 11 here, the rural 2-lane roads that you see, the rural multi-lane highways, there's no safety performance function for T intersections, basically 3-legged signalized intersections, T intersections for either rural 2-lane roads or rural multi-lane highways. And so again, that's a limitation. And again, we'll see some other limitations as we dig deeper into this. But again, these are the ones that are covered in the Highway Safety Manual. Everything with a check here. Everything that's not checked, and anything that you don't see there, like urban 2-lane sections or urban and suburban collectors, are not in existence in the Highway Safety Manual. And so again, I want to make you aware of the limitations and the things that aren't covered as well. Well, let's start with what is a safety performance function. Let's look at what safety performance function is and the purpose of the crash modification factors. Well, the safety performance function, it's a mathematical regression model for the roadway segments and intersections. There are different mathematical models for segments and for the different intersection types. They're developed from data from a number of similar sites. And I'll talk about this a little bit later as well, dig a little deeper into what that really means. So they've taken data for a number of similar sites, run it through this mathematical regression to come up with a model for what's the safety performance, that we can expect for these various roadway types. They're developed for specific type site types and base conditions. And this is what I was talking about before. We start with the ideal conditions, and then we'll apply these crash modification factors for anything different than the ideal. Typically, we want to make the safety performance function a function of, typically all they want is AADT. So you put in the volume and you get out an expected crash number. And so you put in a very few variables into the SPF, the safety performance function, and you come out with a estimate of the crash performance of that roadway type. And again, what we're trying to calculate is the expected crash frequency, how many crashes per year for that base condition, the base geometric and traffic conditions. And then, like I said, the crash modification factors are the adjustment factors. Just like in the capacity manual, we started with a certain saturation flow rate, if you will, for a particular type of road. And then you had adjustment factors if your lanes were something other than 12 feet, if your terrain was not level and all that kind of stuff. It's the same thing here. We start with these base conditions, and the safety performance function is adjusted. The value that's computed in the SPF is adjusted by these crash modification factors, these adjustment factors, for anything different than the base conditions. And again, it's trying to account for the difference there between whatever the base conditions are and your site-specific conditions. Okay, so these crash modification factors are used to adjust that safety performance function calculated value. And so if your crash modification factor is equal to 1, all these CMFs are multipliers. And so if your CMF is equal to 1, that means you're the same as the base conditions. If your CMF is less than 1, then whatever treatment you've got here is going to reduce the number of crashes. If your CMF is greater than 1, your treatment, whatever you're doing there, increases the expected number of crashes. And so just so you understand the relationship, you've probably all seen this before, the crash reduction factor, CRF, is equal to 1 minus the crash modification factor, CMF. But here is something that no one ever tells you. I've never heard anybody tell me this in any of the highway safety manual trainings that I've been, write this down or circle this, carve it in your desk or whatever. Here's a very important note. The CMFs, crash modification factors that are in Part C of the Highway Safety Manual are to be used only to adjust those calculated safety performance function values. Okay, these are not the same as the CMFs that are in Part D of the manual or those that you'll get from the CMF clearinghouse. I wish they had really used a different terminology here, because what these are really adjustment factors for the safety performance function, the SPF. So the CMFs that are in Part C are just the adjustment factors for the SPF, and they are only to be used within the context of that SPF in that particular chapter. So for instance, you wouldn't take a crash modification factor for a 2-lane rural road and use that same one for a rural or a multi-lane rural highway. That's a different chapter. They've got different CMFs. And so you want to make sure you're using the CMFs that are in Part C, the predictive method, if you will. You want to make sure you're using those in their proper context and not using them out of their context. So again, that's just something I want to emphasize, because I've been in trainings where, the instructor would say, well, you can kind of use them, just have to be careful. No, they haven't been calibrated for use for anything other than those safety performance functions. So you don't want to use these crash modification factors that are applicable to that safety performance function for anything other than that safety performance function. And so that's just something critical that you really want to make sure you're aware of if you're doing highway safety manual analysis, is you're using the right crash modification factors. All right, so let's look at some of these things. Here is the safety performance function for rural two-lane roadway segments, for a segment of rural two-lane roadway. And it's basically a function of the AADT. You put in the length of the segment, and then there's all this other stuff here. And this is one of the things really gets under my skin a little bit, in that the Highway Safety Manual goes to great lengths to emphasize that the relationship between volume and crashes is nonlinear. It's a nonlinear relationship. If you double the volume, you're not going to get twice the crashes. Well, when you really look at this particular equation for rural two-lane roadway segments, and especially when you graph it, what you see is a straight line. For this particular one, the regression brought back a straight line. And so this is what the SPF for rural two-lane two-way roadway segments looks like. And the reason for that, they did something, it's an illusion here, if you will. This last term of the equation, they show this e to the negative 0.312 power. Well, that's not a variable, that's a constant, and that's the constant, 0.732 when you work it out. And so really, for a given length of roadway, if L is a constant, and so you're looking at the same length of roadway, if you double the volume, you're going to get twice as many predicted crashes. And so that's just the way it worked out for this particular model. That's the way the regression worked out. And so again, I thought it was kind of, I don't know, it was an illusion, if you will, to talk about how, oh, it's a nonlinear relationship. Well, in this case, it is clearly a linear relationship. Now, like I mentioned, for any of the safety performance functions, there is a base set of conditions, and this is what it is for a rural two-lane roadway. For a rural two-lane roadway, it's assumed that you have 12-foot lanes, 6-foot shoulder width, paved shoulder. The roadside hazard rating is 3, and that's something you really need to go to the Highway Safety Manual to dig into if you want to dig into that a little deeper. Basically, the roadside hazard rating, it's a number between 1 and 7. And roadside hazard rating of 1, everything is completely flat. There's nothing you're going to hit if you run off the road, and everything's flat and level, and you can leave the road and then re-enter the road without any issues or something like that. And so, I mean, roadside hazard of 1 is extremely, better than ideal conditions, if you will. And the other extreme, roadside hazard rating of 7, is where you have rock cliffs just a foot or 2 off the edge of the roadway, and so either you crash into the rocks or you fall off the cliff, and so that's the other extreme. And so the roadside hazard rating of 3 is kind of indicative of typical design conditions where you have good clear zones and there's no obstacles in the roadside and that kind of stuff. And so it's one of those things, it's a little subjective, that roadside hazard rating, and there's some pictures in the Highway Safety Manual that kind of guide you through which one should I pick. And again, I refer you to the Highway Safety Manual to really understand what that roadside is. Anthony, can you hear me?
Yes.
Okay, yeah, I just got a thing here said my audio had disconnected, but okay, we're still on. Okay, good. All right, and some of the other base conditions you can see here, it's assuming 0 grade, driveway density around 5 driveways per mile or less, no horizontal curvature, no vertical curvature. And so these are the base conditions. And what this means is for each of these things, there is a crash modification factor for that safety performance function. So for each of these items, there is a crash modification factor for anything other than this ideal condition. So for instance, if you had lane width that was 11 feet, you would apply that crash modification factor. If your shoulder width was different, you would apply that crash modification factor, and so forth. So these are the different things that there are crash modifications for that safety performance function for 2-lane rural roadways. All right, hope that's somewhat clear. And then so what we do is, again, we run our safety performance function, and then we apply all those crash modification factors that are applicable. So if we have narrow lanes or wide lanes or whatever, or if our shoulders are different, if we have a different roadside hazard rating, whatever, we apply all those different crash modification factors. They're multipliers. And then there's one other multiplier here, the C sub R at the end, that's a calibration factor. It's a local calibration factor. And the Florida DOT has done some research and come up with what are the local calibration factors for the state of Florida. And so, again, you just use all those appropriate factors, and that's how you get your predicted average crash frequency. All right. And so, again, like I mentioned, these are all the different things, for that rural 2-lane roadway segment. And for each of those items, there may be a crash modification factor that needs to be applied. Let's look at lane width. Let's say you did have something other than 12-foot lanes. And so you would go into this table here in the Highway Safety Manual. And, again, we're looking at 2-lane rural roadways. And so, you apply in AADTs and looking at what is the lane width that's there. And then one of the factors that's also in the equation here is, what is the proportion of crashes related to this particular crash modification factor, or this particular type of roadway. And so the proportion of related crashes, the note kind of tells you single vehicle run off the road, multiple vehicle head-on, and opposite direction side swipe, same direction side swipe, are the kind of things that may occur that would be related to this particular type of roadway. And so you need to know how many or what proportion of the crashes are in that group of related crashes. The default value is 0.574, which means 57.4% of the crashes are of those types listed there. But that's the default value. If you have something like the crash data management system in District 7, you could get better data. You could actually compute it based on the observed crashes. You could also use CARS or Signal 4 or something to get that data if you wanted to. But anyhow, this is the kind of stuff you would have to do, these calculations, for that crash modification factor for that particular safety performance function for your rural 2-lane road section. All right, so that's for a segment of 2-lane rural road. But you might be asking this question, well, what about the intersections? What about the intersections along this 2-lane rural road? And that's a good question. There's safety performance function models for the intersections as well. And so here they are, the 3-legged stop controlled intersection. And this one's, non-linear. You can see it's, exponent, that's e to this power, and there's natural logs and all kind of stuff. And so you go in here with the AADT of the major roadway and the AADT of the minor roadway. And again, it's e to this power with, all these natural logs and that kind of stuff. And you come up with this number of expected crashes per year at that type of intersection. And similar things for a four-legged intersection or four-legged signalized intersections. And so again, you're going in with the data of basically just AADTs, so the major street and minor street, and coming up with what you expect the crash experience to be. But again, these are the safety performance functions, the SPFs, and then each of these SPFs also have base conditions. And anything different than the base conditions, you have crash modification factors for. Only a few base conditions here for the rural two-lane intersections. What's the skew angle? Are there left turn lanes? Are there right turn lanes? And is there lighting? And so, again, there's CMFs for each of those things. You know, it's interesting to me, you know, some of the things that aren't included here. You would think grade might have some impact on crashes at an intersection. You know, if you have a steep downgrade or a steep upgrade, you know, that's going to impact the ability of vehicles to decelerate or accelerate. And so you would think that might have an impact on the crashes, but it didn't show up as a significant variable, and so it's not included here. And so, again, it's just one of those things. I think future research may start including some of those other things, but in the research done so far, that didn't show up as a essential variable. All right, so this is how we pull it all together. The performance of our overall segment of roadway. We do the roadway segment portion where we pull the roadway segment SPF and all its appropriate crash modification factors, and that gives us a number of predicted roadway segment crashes. And then all the intersection crashes, we do all the different intersections along our whatever the limits of our segment of roadway are. For each of those intersections, we sum up all the predicted intersection crashes using the SPFs for the intersection on all of the crash modification factors appropriate to each of those intersections. And so this is how it all starts to come together. We combine the predicted roadway segment stuff and all the intersection crashes, and that gives us the total crashes for the entire segment that we are trying to analyze. And so I hope that's starting to look a little clear. I know it's kind of fuzzy and it looks a little complicated, but it's really fairly simple. I mean, it's just there's a lot of steps in the process. So that's, rural two-lane roadways, chapter 10, if you will. We're going to fly through chapter 11, part C, and, here it's rural multi-lane highway segments. And, the safety performance function looks like this for undivided roadway sections and looks like that for divided roadway sections, which they don't look too different, do they? All flip back and forth. No, they kind of look pretty similar, don't they? Okay, so anyhow, the basic formula there, the layout of it is pretty similar, and the only thing that really changes are the regression coefficients. And so, of course, there's a table that gives you the regression coefficients, and so, again, it's just a process of looking up all the different coefficients, and it's, based on, whether you're looking at total crashes or just fatal and injury crashes or whatever. And so you pull those out of the table. Here it is for divided. The previous one was undivided. And so again, just different coefficients for divided versus undivided. Now the base conditions for undivided rural multi-lane highways, lane width is 12 feet, shoulder width is 6 feet. Paved shoulders, your slopes are 1 to 7 or flatter. No lighting, and no automated speed enforcement. And that's it. Those are the base conditions that have been identified and for which there are crash modification factors if you have something different than that. So again, if your lane width is something different than 12 feet, there's a crash modification factor. If your shoulder width is different than 6 feet, there's a crash modification factor. If you do have lighting, there's a crash modification factor, and so forth. It's, again, interesting to me that speed doesn't show up here. I mean, you would certainly think speed would have an impact on crashes, and certainly the severity of crashes. But again, talking to the researchers, it did not show up as a significant variable. So speed isn't, again, grade, whether you're on, uphill, downhill, whether you have rolling terrain versus level terrain, it seems to me that would have had some impact on crashes, but again, it didn't show up in the regression models as being significant. And so, again, this is for undivided. For divided, slightly different list: lane width, right shoulder, median width, lighting, automated speed enforcement. And again, you can see the base condition for this divided rural multi-lane highway assumes you have a median width of 30 feet. If you don't have 30 feet, then again, there's going to be a crash modification factor that's applicable and appropriate there. All right, so again, crash modification factors for these things, but there's a lot of things that, again, I look at and say, well, you mean that wasn't a significant factor? I mean, I can't believe grade and speed weren't significant, but that's what the research shows so far. So that's where we're at. Here's another important thing you want to know about this chapter. Multi-lane highway refers to facilities with 4 through lanes. Facilities with 6 or more lanes are not covered in Chapter 11. And this is a quote. This is what it says in the Highway Safety Manual. If you want to look for yourself, that's page 11-2 of the manual. Listen to what it says. And so, it says multi-lane. Multi-lane means 4 lanes. So it's a 4-lane cross-section, and that's what it means. I mean, it'll handle, the 5-lane section where it's undivided with a 2-way left turn lane, but a facility with 6-lane, a 6-lane section is not covered in Chapter 11 of the Highway Safety Manual. So that's an important thing to know. All right. So again, same kind of thing for the intersections. We talked about the segment thing, and then looking at the intersections, again, there's safety performance functions for some of the intersection types here, but what you'll see is those 3 types of intersections are covered. The signalized T intersection is not covered for a rural multi-lane highway, so a 3-legged signalized intersection is not covered. And again, I think that's a significant limitation. It probably will be filled in the next version of the Highway Safety Manual, but as of right now, it's not covered. All right. Here's something interesting. Again, this is a quote out of the Highway Safety Manual, and I think the part that's bold is my emphasis here, but it says the safety performance functions for 4-legged signalized intersections on rural multi-lane highways have no specific base conditions and therefore can only be applied for general predictions. No crash modification factors are provided for 4-legged signalized intersections, and predictions of average crash frequency cannot be made for intersections with specific geometric design and traffic control features. Okay, what does that all mean? Well, it means that the predictions you get out of here are incredibly imprecise, that they need to be taken somewhat with a grain of salt, because there are a lot of variables when you're looking at an intersection, and as of right now, the Highway Safety Manual for this intersection type, 4-legged signalized intersections on rural multi-lane highways, isn't accounting for anything, isn't accounting for any of the different design features. And so I would say that the predictions you get out of this are incredibly imprecise and, like I said, need to be somewhat taken with a grain of salt. But this is what the SPFs look like, the safety performance functions. This is what they look like, and for different highway intersections. And again, you can see it's the same kind of thing. You go in with the AADTs and come up with a estimated crash frequency. And the coefficients that went in those equations, the ABCs, it's just a simple table lookup. And again, you grab the number out of the table, stick it in the equation, and away you go. It's, again, not complicated, but there's just a lot of steps in the process. And again, SPF coefficients for 4-legged signalized intersections for total and fatal and injury crashes. And so, again, it's just like what the Highway Capacity Manual was in 1985. Table lookup, you pull the number out of the table, stick it in the equation, and go. But again, a lot of steps. And so again, same way how you pull it all together, your roadway segment crash number added to all your intersection crash numbers, and that's what gives you the total crashes over the segment of roadway that you're analyzing. All right. We'll look quickly into Chapter 12, Urban and Suburban Arterials. It's the same kind of thing, and it actually has the same kind of note. And again, this is a quote straight out of the Highway Safety Manual. Chapter 12 does not address arterial facilities with 6 or more lanes. So it also is limited basically to a 4-lane cross-section, or it will handle the 4-lane cross-section width, the center two-way left turn lane. But a arterial with 6 or more lanes is not covered in the highway safety manual. And what that means is for many of our busy urban arterials that we have all over Florida, it's a 6-lane section. Sorry, HSM doesn't give you anything to work with. Now, I've heard some people say, oh, well, you just kind of use the 4-lane model. No, you can't. You really can't. It has not been calibrated. You've got different crash types on a 6-lane roadway. Your volumes are in a different scale on a 6-lane roadway versus a 4-lane roadway. So you really just cannot use the predictive methods in the highway safety manual on 6-lane facilities. I mean, that's what the HSM says. That's what the researchers wrote here. It does not address facilities with 6 or more lanes. And so that's another important thing that you need to be aware of, a limitation, if you will, of the highway safety manual analysis. All right, in 2014, that supplement to the first edition came out, and it added basically it added 2 Part C. It added 2 things, a predictive method for freeways and a predictive method for ramps. Well, freeways and ramps are really outside the purview of the local agencies, so I'm not going to spend any time on that today, but it's there in the supplement if you're interested in. There is predictive methods for freeways and predictive methods for ramps. All right, so that was Part C. Again, Part C is all the predictive methods, and these safety performance functions and the associated crash modification factors that go with the safety performance functions. And like I said, don't use the crash modification factors out of Part C for anything other than calibrating or for use with those safety performance functions. We get to Part D. Part D is all about crash modification factors. But really Part D of the manual, which is the 3rd volume, volume 3, Part D is really obsolete. Instead of using Part D of the manual, what most people do nowadays and what most people would recommend is to go to the Crash Modification Factor Clearinghouse. And so the Crash Modification Factor Clearinghouse gives you up-to-date research. So there's a lot more crash modification factors now than there was when that 2010 manual came out. All the ones that are in Part D printed in the 2010 manual are in the Crash Modification Factor Clearinghouse. So if you're really looking for crash modification factors, and again, these don't go with the safety performance function, these go with other things. If you want to see what is my crash modification factor for putting in rumble strips on a particular type of roadway, well, you can look it up on the CMF Clearinghouse, and you can see what your CMF will be for that particular type of improvement. All right. Anthony, I think you got a poll question here on CMF Clearinghouse.
Yep, I will pull that up now for you. Similar scale to what we had before on a scale of 1 through 5, 1 being I can spell CMF and 5 being I have used a clearinghouse to select CMFs. What is your level of experience with using either Part D CMFs or the CMF clearinghouse? That's a really interesting split so far. We have an all or nothing going on in the audience.
Yeah, it looks like a fairly good number of people have used the clearinghouse.
More people are using the clearinghouse that are using the highway safety manual, which maybe is indicative of folks are just using benefit cost calculations old school way instead of using predictive methods.
Yeah, and I mean, I think part of it is, as we've gone through, the predictive methods, like I said, it's really not complicated. There's just a lot of steps. There's a lot of pieces to the puzzle, if you will. And until that's really automated in something, like what they did with the highway capacity software, it takes way too much time for people to do that.
All right, we'll go ahead and close this poll and share the responses. 40% of the audience can spell CMF, 20% level 2 knowledge, 15% level 3, 5% level 4, and 20% of the audience has used the clearinghouse or the Part D to select CMFs.
Okay. Well, that's good. That's good. So, I mean, a portion of the audience at least has used the CMF clearinghouse, and the web address, if you can't make it out at the top of the screen, it's cmfclearinghouse.org. It's a great resource. It's a really good resource for what can I expect when I do this particular type of improvement? What can I expect in terms of crash modification factor? And so a lot of good information there, and I'll leave it there as a resource that you definitely want to check that out. Well, one of the real questions is, gosh, some of this stuff does seem pretty complicated. Where can I get help on using the Highway Safety Manual? Well, highwaysafetymanual.org is the website to go to. There's a lot of online training, links to other related tools, safety analysts, and IHSDM is the Interactive Highway Safety Design Model, and that implements a lot of the highway safety stuff. Basically, IHSDM, I've never used it, but talking to people that have used it and the developers of it, the intent is you can feed a roadway file, a roadway CAD file into IHSDM, and it will look through all the design features that are in your roadway design file, in your CAD file, and identify places where you might want to look at the design features, places where you can expect more crashes or less crashes and so forth. And so the IHSDM is, like it says, an interactive highway safety design model, and it so helps you to look at, okay, where do I have constraints, if you will, that might be indicative of increased crashes, and so allows you to go back and say, well, can I make design changes there and make my roadway safer? And so there's a lot of good tools on highwaysafetymanual.org. That's what the website looks like. And like I said, there's a lot of stuff there you can click on, learn more about the Highway Safety Manual, check out the new stuff that's out there, look for errata in the HSM and that kind of stuff. So a lot of good, useful tools, good information, training information and stuff there at that website, highwaysafetymanual.org. All right, why should we be worried about this anyhow? Why should we use the Highway Safety Manual? Well, again, what's required, especially if you're going after federal funds, and what we want is to have quantitative estimates of our safety performance. We want a data-driven process. And so when we have more reliable estimates, we can have better decisions. We can have better safety cost effective decisions being made. And so we can use our money more wisely. And so the estimation methods that are in the Highway Safety Manual are based upon good science, good research, and they improve upon much of the current practice of safety engineering. And again, what we're really looking for is a data-driven process so that we can account for these things and have quantitative safety estimates where we can identify the sites with the most potential for reducing crash frequency or reducing the severity of crashes. We can identify crash patterns and what treatments should be put in place to address those patterns. We can conduct real economic appraisals of different safety projects and what the real benefit is versus the cost. We can evaluate the crash reduction benefits of the treatments. We can estimate the effects of different design decisions on reducing crash frequency and reducing especially severe crashes or fatal crashes. And again, the main thing we want to do is make sure safety is considered along with all these other things, the right-of-way, environmental impacts, costs. We want to make sure safety is one of the considerations that is part of the design process. Now, there is something, the HSM methods complement the design guidelines because what we're trying to get to is not just what we call nominal safety. Nominal safety is where, okay, I've met the design standards, and I presume that means we're safe. But where we go from nominal safety to something better than that, which is substantive safety, where we're looking at actual crash numbers, the actual crash performance. And so nominal safety is often what's seen when we do design, nominal safety. Oh, well, we designed it to the standards, so we presume that's going to be safe. But what is the real safety performance of the roadway? That's substantive safety. And here's the real difference between nominal safety and substantive safety. Nominal safety it's an absolute. It's like, okay, let's say you're on a freeway and you've got 36-foot clear zone. If I've got a tree that is 35 feet 11 inches from the edge of travelway, oh, that's unsafe because that's less than the clear zone standard. If that tree was 36 feet 2 inches from the edge of the travelway, well, that's outside the clear zone. That's safe. Well, I mean, you've just moved the tree 3 inches. I mean, so is that really that big a difference? And that's the difference between nominal safety and substantive safety. And this is one of the things, that concerns me somewhat with some of the things we see going on. The department's, Florida DOT is putting in a lot of trees just outside the clear zone in areas that didn't have trees before. And I'm hoping that's not going to result in more crashes. But when you start doing that kind of thing, yes, I like trees and I like beautiful roadways. But if I say that I'm going to put this tree, well, just 1 foot outside the clear zone in a roadway section that in the past has not had trees, am I making that roadway safer? Yes, I might be making it more beautiful, but am I making it safer? And that's the difference between nominal safety and substantive safety. All right, some of the key safety principles in design. The knowledge really is imprecise, and judgment is essential when you're doing safety work. Like I said, meeting the standards doesn't always necessarily make a highway safe. Again, that's the difference between nominal safety and substantive safety. And many of the important features of highways are not determined by standards, but it's just years and years of experience. You see, well, putting in those large radius on the right turn lanes tends to increase the speed of vehicles going around those right turns, makes it a little more hazardous for pedestrians and other users out there. And so it is a balance we have to deal with, balancing efficiency and safety. All right. The role of road design and crash prevention. Certainly good design can reduce the incidence of human error where the human makes a mistake. So good design tends to encourage good behavior. The other thing we can do in design, even if the human does make an error, we can, if the design is good and the roadway is forgiving, reduce the chance of the human error resulting in a crash. And the other thing we try to do, even being more forgiving in our roadways, even if there is a crash, we want that crash to be survivable and not a fatal crash. And so these are the things we try to do in design, is reduce the incidence of human error. Even when an error occurs, can the human recover without a crash? And even if there is a crash, can they survive the crash? And these are the kind of things that we try to do through good roadway design practices. Well, how a particular section of highway or intersection is built, the engineering of it, and how it is operated impact the number and the severity of crashes. And that is certainly true. So if it's designed well and operated well, then again, hopefully you can reduce the incidence of error, reduce the number of crashes that occur because of error, and reduce the severity of the crashes when they do occur. All right, so again, we want to use the Highway Safety Manual because better safety analysis tools support better decision making. We can make more cost-effective safety investments if we can analyze our safety approaches better, and that results in more lives saved, fewer injuries, and less fatalities. And so that's what we want to do, is maximize our investment, saving more lives, reducing injuries per dollar invested. All right, the Highway Safety Manual certainly improves upon current practice. Safety measured in terms of expected long-term crash frequency. There's other things you can use to estimate safety, just crash counts. We looked at the predictive methods. And then there's something that's often talked about when you hear highway safety talk about, the combination of crash counts and the predictive methods, and that's the empirical Bayes method. And I'll talk about that in a few slides here. Predictive methods, model the variability in crash data. And when you use, especially when you're using the empirical Bayes, it compensates for regression to the mean and accounts for changes in traffic volumes. That is the primary variable that goes into those safety performance functions. And so again, the Highway Safety Manual predictive methods are all about using the safety performance function, using the appropriate crash modification factors, applying that state or local calibration factor. And then the empirical Bayes weighting is where you blend your real-time crash information, your crash data, with the predicted crash data. And again, that just helps you have a better estimate of your safety performance. These HSM predictive methods are designed to be predictive, which means we're getting from being reactive to safety to where we're proactive. So we want to be proactive, ahead of the curve. And again, that's why we want to get to where hopefully we're using the predictive methods, predicting what a roadway segment may perform like prior to it being built, so we can get some of these changes into design before the crashes start occurring. And so again, that's what the predictive methods are all about. All right, in summary, we need these quantitative estimates of safety performance in order to make planning, project development, and design decisions. When we have more reliable estimates, we can have better decision making. And the estimation methods we have in the Highway Safety Manual are based upon good science, and they do really improve much of the current practice. Safety considerations should be a part of every transportation project. All you need to do is just see the mission statement of your agency or your organization. There's probably something in there about reducing crashes or making a safe roadway environment. We can reduce crashes and save lives, and we need to get to where we are thinking proactively about safety. And that's why we need to be thinking about using the procedures in the Highway Safety Manual. A few closing thoughts on just the Highway Safety Manual and some of these things. How good are the regression equations? Well, the regression equations are based on data from all over the place. And I mentioned, the list of variables that exist, the base model, and then there's these other variables for which there are crash modification factors. And there are some that, I think should be in there that apparently are not, or at least not yet. And so when you don't control for some of those things, and even trying to control for some of those things, there's a wide spread of the data. And so the regression equation, though, just gives you a line or a curve, and when you plug in the number, you get some point on that line or curve. And again, you can see the data that went into developing that regression equation is kind of spread all over the place. And so there are factors in the analysis that talk about the dispersion coefficient, the dispersion of the data, how dispersed the data is. And, again, this is just getting an estimate, but like I said, you can see on the screen how the data is spread all over the place. So you just want to be aware it's not super precise. And so certainly when you run your safety performance function, yes, mathematically you can carry it out to 10 digits past the decimal point if you want to, but that's really ridiculous, I think. And so, 1 or maybe 2 beyond the decimal point is about as far as you really should go with it. All right, another thing you often hear about is regression to the mean. And so what does regression to the mean mean? And so regression to the mean, and this is definition straight out of the Highway Safety Manual, is RTM, regression to the mean, or selection bias, refers to the bias created by the natural fluctuation of crash frequencies, which may lead one to draw incorrect conclusions about countermeasure effectiveness or sites with potential for improvement. That's a lot of words. What does all that really mean? And this figure is in the Highway Safety Manual and in some of those other references that we gave you in the download pod. And basically what it means is your crash experience is all over the place. You go from year to year and you'll have a sudden jump in crashes. The next year it'll drop even though you didn't do anything. And so why did that drop so much? Well, it's just because it's regressing to the mean. Here is the long-term mean of your crashes. And so let's say, gosh, we're here in this year and say, wow, man, our crashes are gone way up, we're way high. And so you do some feature and the next year you drop to where you're down here. Well, did you really reduce this many crashes? No, your long-term crash experience is where that expected average crash frequency line is. And so if you dropped to somewhere down here, well, this is how much you really did. Whatever the number of crashes is between this long-term expected crash frequency and what you experienced, is how much you really got out of it. And so, again, that's what regression to the mean really means, is there's a whole lot of fluctuation typically in your crash numbers. And sure, your short-term, here's your average for those 3 or 4 years. Here's your average for those 3 or 4 years. But if you have 10 or 20 years of data, here's the long-term expected crash frequency. And that really brings me to, hang on, one other thing. Yeah, what is this empirical Bayes thing? Empirical Bayes it's something that was developed, actually hundreds of years ago by the Reverend Thomas Bayes, who was a pastor during the Protestant Reformation, but he dabbled in statistics on the side, but he came up with the empirical Bayes method, and it's still used not only in safety analysis but in other fields as well, and recognized as very statistically robust and very useful. And what the table shows basically is the way that you account for regression to the mean bias is by using these empirical Bayes adjustment. And the empirical Bayes adjustment, basically, you have a predicted crash frequency that comes from the safety performance function. Again, you go in with your AADT, you get a point that's on that line. And here's your predicted frequency here. If you have observations, your crash counts show something maybe higher than that. The empirical Bayes is a process by which you blend the observed frequency of crashes with the predicted frequency from the SPF, and you get what's called the expected frequency. And so when you hear people talking about using the empirical Bayes, to use the empirical Bayes, you must have both SPF, you must have a valid safety performance function, and you must have real crash data, because that's what empirical Bayes does, is blends your real data with the other data from the SPF. And so that gives you, what is called the expected frequency. So it blends the predicted with the observed and gives you something that is expected. And there's an underlying assumption there, and it's really one of the big underlying assumptions to all of the Highway Safety Manual predictive analysis, if you will. The underlying assumption is that the average crash rate at my particular roadway for 100 years, if I were to just have the same volume on this same roadway for 100 years, is equal to average crash rate for 1 year at 100 similar sites. And so basically I've got 100 other sites and I average all their stuff. And that would be the same as what I would expect at my site over 100 years. So basically that all sites, if we've controlled for all the other things that we have crash modification factors for, all sites are essentially the same. And so, that's the assumption that underlies the use of the empirical Bayes method and basically the safety performance functions. So again, remember, all that's based on our safety performance function and the dispersion of data that feeds that. So are all those sites really similar? Well, maybe, but again, that's why, like I said, don't use 5, 6, or 10 decimal points in your calculations when you're using HSM analysis. 1 or 2 decimal points is as accurate as you could possibly think about being. All right, we've covered a lot. We've gone about an hour and a half here. So I think we've covered what is the HSM, who should use it, when should you use it, and how to use it. Where can you get assistance? I gave you that website. And why should we use it? I think we covered that pretty well. So at this point, I'm going to open it up for any questions. There is a poll question, Anthony, if you want to ask that now.
I will go ahead and bring up that poll question while folks are typing questions. There are no questions in the chat at the moment, so I'll give folks a few minutes to ponder all the information we received today. It was quite a bit while we do the last of the poll questions. Launch. So on a scale of 1 to 5, like we have been doing before, ranging from I knew all of this and learned nothing today to I learned a lot of things I didn't know, how much did you learn in today's webinar? I imagine we'll get a mixed bag here. We'll see. A few more seconds to answer. All right, we'll close that poll and share the results. Looks like you've done your job. We have 38% of the audience, level 3. They use some information and they don't know others. 43% level 4 as far as how much they learn, and almost 20% of the audience learned a lot of things they did not know. So I would call that mission accomplished.
That's good. That's good. Yeah, definitely. Mission accomplished there. So that's good. I'm glad you learned something useful. And again, the resources that are in the handout pod and the others that are on the Safety Academy website, there's some really good information in there that will help you if you're going to be doing highway safety manual type analyses. All right, any questions in the chat pod?
Yep, we've got a handful here. We have a very informative, I must leave for a meeting, thank you for the information. The clearinghouse website is very simple. There are no calculations, that is somewhat limited. After this wonderful webinar, when would you suggest using the highway safety manual versus the clearinghouse on already existing conditions, besides the fact that the CRF is not found on the website?
I mean, for most analyses, I know most people are just using the stuff on the CMF clearinghouse. It is very simple, but again, you have to be really, really careful in how you use that information. I did another webinar on the proper and improper use of crash modification factors. And, if you go back to the website, you can look at that webinar if you didn't see that one, but because it is really easy to misuse those crash modification factors off that website. But the question really is, when should you go beyond, if you will, the CMF clearinghouse and use the predictive methods? And again, it really depends what you're trying to accomplish. If you're just trying to see, okay, what would happen if I added this one treatment to this existing roadway? Certainly the CMF clearinghouse is where you want to go. But when you're looking at especially long-term big roadway projects and design decisions, that might be where you want to get into running the predictive models, especially if you're looking at a big project where you're going from a 2-lane roadway to a 4-lane roadway. And you want to look at what my 4-lane roadway might perform like. Then certainly, getting those predictive models in there is a good application. That's the kind of thing the HSM is really designed for. So I hope that answered the question.
There's a question about influence areas. What distance would you recommend to use as the intersection influence area in a rural setting?
Oh gosh, I'm going to take a "it depends" approach to that. Yeah, there is some guidance in the Highway Safety Manual, and I don't have my HSM here with me in front of me, but there is some guidance in there on what really constitutes the influence area of intersections. And certainly it is, beyond just the stop lines, certainly. But yeah, I don't recall off the top of my head what guidance it gives, but there is guidance in the Highway Safety Manual about those influence areas. That's an excellent question.
Something I've always been interested in, Larry, and we talked about this a little bit before we went live to the audience as far as the application. We learned a lot of theory. We saw the equations, but are there any places where, almost like a workshop, where here's a location and we're going to walk through and step by step look up the equations, apply them, and kind of the old methods versus the new methods, using the Highway Safety Manual, using the predictive methods? If someone is completely new to the Highway Safety Manual, how do you even get started? I mean, just open it up to page 1 and start reading, or are there any guides or, kind of workshops that someone can see?
Yeah, that website, highwaysafetymanual.org, does have some training videos there, and I believe they go through some examples like that. Definitely, I would not recommend anyone pick up the Highway Safety Manual and start reading it. Unless you're suffering from insomnia, then by all means, that's the thing to do. But other than that, yeah, it's a very difficult thing to read. It's a very difficult thing to even find your way around in. My personal opinion, I'm hoping that when they get to version 2, they do some reorganization. The information is hard to find. It's not very user-friendly, if you will, I don't think, personally. That's my personal opinion. I mean, there's a whole ton of stuff in there. And like I said, when I was first looking at it, it really took me back to my grad school days with that 1985 capacity manual. The 85 capacity manual actually was laid out pretty well and pretty easy to go through, much more so, I think, than the Highway Safety Manual. But it... similar in that, like I said, you start with the safety performance functions, and it's table lookup for the A, B, and C, exponent variables for some of the equations. It's table lookup based on a few variables, and then all the different crash modification factors. There's different formulas in there, and table lookup for pulling all that stuff in. And so, again, to me, it just reminded me of my old grad school days 30 years ago, and the kind of stuff we used to do when doing highway capacity manual analysis by hand. It's, like I said, it's not complicated per se, but, I've done, capacity analysis of signalized intersection by hand, and you do one intersection by hand, and with all the worksheets that were there, all the things you had to look up in the tables, it took you about a day. I mean, it took about 8 hours to do one intersection. Now with the software, you do that same analysis, and it takes you 8 minutes or, even less. And so that's, the order of magnitude that the software, being able to look up the stuff in the tables, you know, and do all that kind of stuff, do the calculations immediately for you. That's the kind of thing that the technology can help us with. Although that is a little scary to think about, you know, that the future is, oh, just throw in your AADTs and poof, here comes a safety number.
Right, black box.
Yeah, real black box for safety analysis, and that really kind of scares me a little bit. That I hope we don't go down that road that far, because again, you know, it is imprecise, and crashes are random and relatively rare events, and so again, thinking that we can be too deterministic with it is, I think, going to mislead us and send us down the wrong path. Did I answer the question in all of that rambling?
Yes. I mean, it's kind of take it slowly. Like you said earlier, it's how do you use the highway safety manual? The answer, more or less, is very carefully. Yeah, exactly. I think it's a good summary of how to take this and approach it. And unfortunately, you know, there are no, like you said, there are only hard copies of it, and it's fairly expensive. So there's a slight barrier of entry, you know, to get all this information, which is somewhat unfortunate.
Yeah, well, actually, they now do have, you can get single-use PDFs. You can buy electronic versions of it, and if you go to AASHTO, I think AASHTO's website, you can purchase, but it's not a whole lot cheaper. It's not like the MUTCD where you can, you know, download it and access it for free. You still have to pay to get the even the PDF version of the Highway Safety Manual.
And those are like single-use license to the. How does that work?
I'm really not sure how it works. I don't have the electronic version of it, but because I bought it when it first came out, so I've got the hard copy, the 3.5 inches on my bookshelf. Dedicated.
Yeah, we have one in the office as well. I would actually be very interested in an electronic copy for no other reason that you can, you know, Control F and find things as opposed to flipping through the pages.
Yeah. Yeah, and I mean, I've thought about getting one, but it's still a few $100s, I think, for the electronic one. And you know, I'm hoping that a version 2 is going to come out sometime in the next few years. And I hate to make that investment for something I'm going to throw away when version 2 comes out. So.
Yeah. Well, there are no other questions in the chat. I don't know if you have any other, you know, last words of wisdom, or Dennis, if you have anything to add about upcoming webinars. I know that we've got the Joe Santos one, which you mentioned earlier during the introduction. The question that always gets asked as well is, where will this video be posted and the presentation posted? The answer to that question is the Tampa Bay Traffic Safety website. Follow the link on the GoToWebinar invitation that got you to this location. This afternoon, I'll convert the GoToWebinar recording and post it onto the website. I guess with that, I'll go ahead and end the recording, and we'll stay on the line for a few minutes if anything else comes up over here. Thank you so much, Larry, for, yeah.
Can I just add one thing? Yeah, if you do want some more, little sales plug here, if you will. If you do want some more information on Highway Safety Manual training, I do have on my trafficsafetyguru.com website, there's the 2 HSM training sessions that I mentioned, and I've got for the folks here on the recording on the local area Traffic Safety Academy, if you enter the code LATSA, L-A-T-S-A, all caps, for a local agency Traffic Safety Academy, get $5 off on the HSM trainings or my 2018 ethics training if you want. So for those 3 things you can access, and if you're interested in more HSM training. So
no, it's a great resource. You want to bring up the website and kind of show folks where those are, kind of some of the topics you have on there?
Okay, yeah, I can do that real quick. You still seeing my screen? Okay,
yeah,
good.
Yes, we are. Because you have quite a few good training webinars on there.
And Anthony, before you go live, I want to say something.
All right, so trafficsafetyguru.com. Yeah, I just updated ethics. So if you're a PE and need your ethics training there, the 2018 one has just been done. I've got a laws and rules course, but it's a couple years old. I'm about to update that in the next week. There's highway safety manual training. I've done a couple of the NCHRP 500 modules and some other things here. And so, yeah, there's a lot of stuff there. It's easy to use and it's fairly cheap. And like I said, if you go there and want to purchase either of the highway safety manuals or the 2018 ethics, just enter the coupon code LATSA, the Local Agency Traffic Safety Academy, in all caps, and we'll take $5 off each of those if you're interested. So help yourself to that. And
great,
thank
you for sharing that.
Larry, this is Dennis. I wanted to thank you so much for the presentation. It was very informative. And I wanted to let everybody know that, yes, we're working on additional webinars for May and June and out beyond July, and that you will get notification of those, additional webinars that are added. You will get a monthly notice at the beginning of the month to tell you about what's coming up. So with that, I'd just like to thank everybody for attending.
And so, yeah, if you're interested in the PDH for this class, just fill out the form and send it to me at the address on the form, and you'll get your PDH certificate.
And again, that's no cost for the PDH for today's class.
That's correct, yes.
All right, well, thank you so much, Larry, for the presentation. I'll go ahead and end the recording now. We'll stay on the line for a few minutes if something else comes up.